Dr. Pat TV, and we are looking at some basic derivative rules. So, hey, you remember when we were doing that stuff before, that whole doing the work in that fraction, that difference quotient, that f of x plus h minus f of x over h stuff, and the limits, and h is going to 0. Basically, what we're going to find out is there's a shorter way, there's a quicker way, there's a shortcut. But before we get to the shortcut, we got to get our power rule, or get our powers going again. So let's practice some powers. Basically, each of these expressions, what I'd like you to do is take a moment and convert them into the appropriate powers. Okay, so all these expressions, 1, 2, 3, 4, 5, 6, 7. I got 7 expressions here. Take a moment, put it on pause, and then turn these into the appropriate powers, because we're going to need to be able to do that for the derivatives. Okay, for this first one, we've got 3 over x squared. And when we do that, remember that if we have a variable in the denominator, we can rewrite it as a negative power. So we're looking at 3x to the negative 2. For the next one, if we've got 3 fractions, we've got a combination of those. Just remember, do each one individually, separately. So what I'm looking at here is for that first term, I've got that 3/2. I separate the numbers from the variables, so I've got 3/2 as my coefficient with x to the negative 1. Remember, if an x doesn't have a power, it's an understood 1, and because that was in the denominator, it's coming from the denominator, we make it a negative 1 power. And then we've got a minus 4x to the negative 2 because there was an x squared that came from the denominator, and we end up with an x to the negative 6. Now for this combination, for this expression, we have the plus sign in the numerator, which means that we can separate it, we can break it apart. So I first write it as 2 fractions, and then we've got x's on top, x's on the bottom. Just remember your power rules, that when you have variables in the numerator and denominator, is that you take the difference of your powers. So for that first fraction, I'm looking at x to the 1 on top, x squared on the bottom. That's a 1 minus 2, give me a negative 1 power. For that second fraction, I've got a coefficient 2, so I bring that out in front. I've got power 6 on top, power 2 on the bottom, so that's 6 minus 2, giving me a positive 4 power. And so that's just rewriting that expression. First thing to do, separate the fractions, and then take the differences of your powers. And now we've got 3 square root of x. Well, if you remember, square root of x is just a 1/2 power. The 3 doesn't get it because the 3 is outside the square root, so only the x variable is getting the 1/2 power. If you're looking at something like 3 to the 7th, or 3 times x to the 7th root, basically, hopefully you remember that, oh yeah, 7th root is just a 1/7 power. And once again, the 3's outside, so the 3 does not get the power. Now I've got a combination of things, so we're playing with things. We've got a fraction, we've got a square root. So one of the first things you can do is you can rewrite that square root as the 1/2 power. And so our next step would be to separate the 2 and the 3, because that would be a coefficient. And we're looking at x's. We're looking at 6 minus 1/2. You may recall that 6 is the same thing as 12 over 2, so 12/2. So it's 12/2 minus 1/2, and that's where I'm getting 11/2. And for this next one, I've got a parentheses. Inside that parentheses is a subtraction. So basically, we're distributing that 3 and that square root. Okay, so each of the terms inside is going to be multiplied by 3 square root of x. Well, for that first one, the square root times the square root is just a plain old x. So for our first result is going to be a 3x to the first power. Now on the second one, I've kind of did 2 steps there. I converted the square root of x to x to the 1/2, and then we have that 6th root x on the bottom there, and so that would be a power 1/6. Just remember to take the difference there. So I've got 3x to the first there on that first term, but for the fraction I'm going to have 1/2 minus 1/6, and if you may recall, 1/2 is the same thing as 3/6, and so I've got 3/6 minus 1/6, and that's where I'm coming up with this 2/6. All right, so basically that does the working with powers. And so now let's look at how could we use this. So our first rule that we have here is that we're going to try and see a shortcut here. We're going to try and figure out, can we come up with a shortcut. Now, we've got all this algebra here. So what we're going to do is we're going to take x squared and we're going to do all that algebra you may recall. We're going to take x plus h, plug it into for the x, and then we'll expand it out. Then we'll subtract an x squared. Then we're going to divide by h, and then we're going to do the limit as h goes to 0. We're going to plug in 0. When we do all those steps, we get 2x to the first. Next, we take x plus h, we put it into the x to the third, expand it out, subtract an original x to the third, divide by h, and then plug in 0 for the h's, and guess what? When we do all that algebra, we're going to get 3x squared. Let's repeat the process. Let's take x plus h, put it into that x to the 23rd, expand it out. I mean, that's multiplying x plus h, x plus h, x plus h. We're doing that 23 times. Get a result. Then we subtract an x to the 23rd. Then we divide by h. We reduce it out. Then we plug in 0 for all the h's. And guess what we get? We get 23x to the 22. So doing all that algebra, this is what we get. Now, we're looking at that, we're going, is there some kind of pattern? And hopefully you notice we started with a power 2, and there's a 2 in front. Started with a power 3, there's a 3 in front as the coefficient. Start with 23. 23 is the coefficient. And then our powers, looks like we're always one less power than what we started with. Is this always going to happen? Yes, it's always going to happen, and we've got a shortcut. Basically, what we've got here as a shortcut is bring down the original power as your coefficient, and then subtract 1 from the power. So that's why you're seeing an n and an n minus 1 there. So that's basically our first rule here is our power rule, and as you can see, we need practice on our powers because when we do the derivative, the shortcut is all about the power. Thanks, and have a good day.